Hello, class. This is Chantel Chisholm, Mrs. Chisholm. I'm coming to you today to work on the practice exam for the comprehensive final. I'm going to make two videos. There are two practice exam parts. There's a part A, which covers the earlier modules, modules 1 and 2, and the first part of module 3. And then you've got the part B, the practice exam part B, where you'll finish up with module 3 and then 4 and 5. So we'll begin with this video with part A. And I'm going to turn off my camera and I will be sharing my screen. Okay, so as I stated, the first part, practice A, or practice exam part A, deals with the earlier modules. And if you recall, module 1 was heavy with terminology. So question number 1 and questions 2 and 3 as well all come from module 1, giving us some information about population versus sample, how we can classify or categorize variables as qualitative and quantitative, and then also ways that we can collect data, knowing the difference between a study versus an experiment. So number 1 says, in a poll of 1,005 men in a country, or in a poll, 1,005 men in a country were asked whether they favor or oppose the use of federal tax dollars to fund research. Among the respondents, 48% said they were in favor. Identify the population and the sample. Okay, so in the beginning, it says in a poll, 1,005 men in a country were asked. So the number of men that they actually surveyed in this poll, that's your sample, okay? The 1,000 men is how many they actually polled for this question. Now, where they pulled those men from is your population. So the 1,000 men came from all the men in the whole country. So your population would be B, all men in the country. That first question is, what is the population? Now, the second part here, number 1, asks us to identify the sample. That would be the 1,000 men that were selected. So that would be C. Okay. Number 2, another terminology question asking us to classify the variable or determine if the variable is qualitative or quantitative. Qualitative, I want you to think quality or characteristic or trait. Quantitative, I want you to think numerical value, okay? Something that is measured, a number, okay? So here, our variable is the responses on an opinion poll. So the responses on an opinion poll, responses would be qualitative. The variable would be qualitative because responses are attributes or labels, okay? Non-numerical, okay? So qualitative is the type because responses would be attributes or label given. Okay. Number 3, determine whether the study is an observational study or an experiment. So first off, an observational study is simply where your researchers are in a room and they did not give the study participants any sort of treatment, any toys, any magazines. They just are in the room observing them in maybe a natural environment. Okay, so an observational study, something like, for example, walking into a classroom and observing in a preschool classroom or something, and observing the students, the 3-year-olds or 2-year-olds, patterns, behavior patterns as far as placing objects in their mouth. You're just watching them in their everyday environment, just observing. An experiment is when you actually give a treatment, okay? When an actual treatment is given. Perhaps you're monitoring the responses of a new blood pressure pill, and you have a treatment group who got the blood pressure pill, and then you've got a control group who did not. And you're trying to monitor those effects after 30 days. Well, because you actually had a treatment group, you actually gave them something, gave them the medication, that makes that an experiment. A treatment was applied, okay? So to answer this question, which one do we have? Observational study or experiment? Let's see. To study the effects of social media on teenagers' brains, researchers showed a few dozen teenagers photographs that had varying numbers of likes while scanning the reactions in their brain. Well, because the researchers actually did something to the group, in this case, they showed the group, the teenagers, the photographs, they actually applied a treatment. So that makes this an experiment. So this is an experiment because it applies a treatment to the teenagers. They all were shown these magazines or these photographs. Okay. So that was number one and or 1, 2, and 3 on the review. And again, your review looks just like this one. Okay. Be aware of that as well. All right. Number 4 is asking us to identify what sampling technique was used. I'll look at this one as well. So, which sampling technique is used and discuss any potential sources of bias. So, bias is basically what can happen to make the sample not be as, I guess, affected by other forces or outside forces. You want to try to eliminate as much bias as you can, but unfortunately, when you're sampling, you will always have some sort of potential bias because the only way to prevent bias is to actually poll or survey or whatever you're doing the entire population. That way you can actually know what everybody's response would be. But again, that's not ideal. So you're going to have potential sources of bias anytime you're sampling. So let's look at this one. It says every 25th person entering a library is asked to choose his or her favorite author from a list of 5 different authors that includes a description of each. So every 25th person entering the library is asked to do this. Every 25th person. So that's how they're pulling their sample. Every 25th person that walks in is a part of the sample or is asked this question. So what kind of method would this be? This would be systematic because you're actually using a rote system to choose your people, to choose your patrons of the library for your sample. Every 25th person is selected. Okay, so that's a systematic way of doing something. Every kth person, in this case, 25th, is selected. Then right here it says what potential sources of bias are present. Let's see. A, people who did not enter the library are not sampled. Well, that's true, but we're only interested in those who actually frequent the library anyway because of the question. We want to know who their favorite author is. So, of course, we would ask those that are going into the library. So that really is not a problem because our population are the people or belongs or are the people who are actually entering the library. So that's not an issue. Part B, the wording of the question may direct respondents toward a particular author. That is true. That could be the case. You could have potential sources of bias depending upon how you pose the question. So you do have to be careful with giving a survey or a poll and it's an open-ended question. You want to ensure that your question is not leading. Okay. The third one, if there is a regular pattern to the people entering the library, the sample may not be representative. Now that is true. So yes, you could have issues with the wording of the question. That could kind of lead your participants. You don't want to lead them towards a particular author. And then also with C, depending upon the pattern, you may have many people who are not able to be a part of your sample because of the timing during the day when they actually frequent the library. So it could be a regular pattern as far as how people or when people visit the library. So yes, that could lead to bias as well. So both B and C. Okay. So again, those were all terminology questions coming from that first section in Module 1. This one also from Module 1, this is dealing with a frequency distribution, so we'll work through this one. On this particular problem, you actually have the frequency distribution given to you. You're asked to find the midpoints and the class boundaries. So what we have right now on our frequency distribution, we have the classes, which are the temperatures, and there are 1, 2, 3, 4, 5, 6, 7 classes. And then you've got the frequency for each class. So each class represents a temperature range in Fahrenheit, and then the frequency for each of those temperatures. So midpoint is simply the middle point of the class. So to get the midpoint, you will add the lower limit and the upper limit together and then divide by 2. So the midpoint formula, I'm going to just put the formula on here for you. And remember, when you do take the exam, I will have all the fact sheets. I'll have those copied to give everybody one, okay? So the midpoint formula would be the lower limit plus the upper limit divided by 2, okay? So for that first class, we would have 32 plus 35. Uh-oh. Try that again. 32 plus 35. Get that sum and then divide that by 2. So our midpoint for class number 1 would be 33.5. And you do not round up the midpoints. You keep them exact. Okay? Oh, I'm sorry. I skipped the first part of this question. Let me do that first. They wanted to know what was the class width. So what you can do is you can look at how all the lower limits are increasing by the exact same amount, or you can look at how all the upper limits are increasing by, again, that exact same amount to actually see what the class width is. So the lower limit of class 1 is 32, then 36, then 40, then 44, then 48. So all of these lower limits have a difference of 4 units. So they have a width of 4, a span of 4 between them. So that would be the class width. Same thing with the upper limits. They're all increasing by 4 as well. So your class width is 4. Okay, I should have answered that first. Then we get to the midpoints. So the midpoint formula, again, is the lower limit plus the upper limit, and then divided by 2. And we do not round the midpoints. Do not round the midpoints. Notice it said type integers or decimals, depending upon what it is. You do not round midpoints. All right, second class. And again, we said the class width was 4, so we could just add 4 to get the next midpoint, add 4 again to get the next one. Or we can just, again, follow the midpoint formula. Take the lower limit, 36, plus the upper limit, 39. Add that together and then divide that by 2, and we get 37.5. Again, the next class, 40 plus 43. Divide that by 2. We get 41.5. The next one, 44 plus 47. Divide that by 2. 45.5. Then we've got the next one, 48 plus 51. Divide that by 2. 49.5. So again, you can see how these are also increasing by 4 every time as well. So you could just say plus 4 more to get the next one, which would be 53.5, and then plus 4 to get the next one, 57.5. Or again, follow the midpoint formula and add the lower and upper limits together and then divide by 2. And you do not round midpoints. Do not round midpoints. Keep them exactly how they come. If they come as a whole number, great. Keep the whole number. If they come as a 0.5 decimal, keep the 0.5 decimal. We do not round midpoints. Okay? For the class boundaries, you will subtract 0.5 from the lower limit, and you will add 0.5 to the upper limit. This is so that you can get the class boundaries. So for this first class, you have 32 to 35. The lower limit is 32, so you will subtract 0.5 from the lower limit, and that gives you 31.5. And then you will add 0.5 to the upper limit, and that gives you 35.5. Okay? Then you have the next one. You will subtract 0.5 from 36. That gives you 35.5 again. Add 0.5 to the 39, you get 39.5. Subtract 0.5, you get 39.5 again. Are you seeing how every time you subtract and add, you get the overlap where one class ends, the next class begins with the boundaries? The reason is because the boundaries are what we would use if we were wanting to graph the frequency distribution. And the graph of the frequency distribution is a histogram. And all a histogram is a special bar graph where the bars touch. Where one class stops, the next one starts immediately. So that's why you see the overlap. You see where one stops, like for example, class number 1 had an upper class boundary of 35.5, and then class number 2 began at that. It had a lower class boundary of 35.5. So where the one before it stops, the next one begins at that very same spot. That's why the class boundaries are important for graphing. Otherwise, honestly, they're so related to the classes that you really wouldn't give them, really, unless you were wanting to graph it. Okay. So for 43, you'll add 0.5. For 44, subtract 0.5, you get 43.5 again. 47, you'll add the 0.5. So subtract the lower, you get 47.5. Add it to the upper, you get 51.5. Subtract, you get 51.5. Add, you get 55.5. And then subtract, you get the 55.5 again, and then add, you get 59.5. Okay? And again, we don't round those either. Okay. So again, all of this right now is still module 1. That was 1.2. And I won't probably work every question, but I'm trying to touch on the ones that I know may have given you a little struggle. Let me try to clear this up. It's a little fuzzy. Okay, there we go. This one is also module 1 where you're given basically a histogram. This is the graph of a frequency distribution, and you just ask questions about it. How many classes? So you would just count how many bars you have. That gives you the number of classes. Which one is the tallest? Or which one is the greatest frequency? That would be the bar that's the tallest. Which one has the least frequency? That would be the shortest bar. So when you do this problem, use the pop-out window to make this bigger so that you can actually see more exactly what these answers will be from the picture. My picture isn't as clear, okay? So use the pop-out window when you're working through this. Number 7, this is asking you to choose the correct Pareto graph or Pareto chart. A Pareto chart is just a special bar graph that places the bars in order from greatest to least. So whichever country, A, B, C, D, or E, had the most medals, that country would be listed first. And it looks like that would be country E. So there's only one graph that has E first, and this has to be A. And then the next country with the next amount or the next greatest number of medals. Actually, I'm sorry. C has 110 medals, so C should actually be first. So D, graph D is the only one that has C first. I didn't even see that. 110 for country C, so country C is first, then country E, then country B with 58 medals, then it would be country D. So the answer there would be D. Okay. Let's see what else we have here in this section. This question brings us to module 2, where it's asking us to find the mean, the median. Here's your data set right here. And it's asking you to find the mean, the median, and I think the mode. Now, the data set is written or given to you in a stem and leaf plot. I recommend from the stem and leaf plot, you writing out the numbers. Do that first, and then put it in your calculator. That's just to ensure that you don't miss any of the numbers when you're entering them in. So the stem is to the left, and the leaf is here on the right side of the bar beside each stem. And the key tells you how to read these. So 3 bar 0 represents 30. So 0 bar 3 would be the number 3. So you got on that first stem of 0, you got 3, 4. On stem of 1, you've got 10, 15, 16, 18, because a stem of 1 and a leaf of 0 is 10. Stem of 1, leaf of 5 is 15, then 16, then 18. Then for the stem of 2, you've got 20, 26, 26, 28, 28, 28, and then 29. Okay. Then going to, and we do have 1, 2, 3, 8. Yeah. Then going to the stem of 3, you got 30, 31, 31, 31, 32, 34, 35, 37, 38. And then stem of 4, 40, 41, 43, 44, 48, and then 53, that last stem. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 values. And I just like to verify that. I counted 28. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so yes, 28. All right, now, I know that seemed like a lot and we haven't even done the problem, but I just like to make sure, because remember, your calculator is not smart. It only knows what you put into it. So if you put the wrong numbers in or you don't put all the numbers in, it will produce all wrong answers and you'll be none the wiser. So I write them down, and then from my list, I ensure that I did write all of them down. And then from this list that I just jotted down, I put them in the calculator. So then we put those values into a list. Remember, to pull up your list, you press the stat key. And edit is what we're about to do. And I've got some things already in some lists. I'm going to clear that out. Remember how we clear? You go up to the name, press clear, and then enter. Not delete, okay? Don't delete. That's delete. That'll delete the whole list. You just want to clear it. So you go up to the name and you press clear right here and then enter. All right, so in list 1, I'm going to put in, just put the numbers in: 3, 4, 10, 15, 16, 18, 20, 26, 26, 28, 28, 28, 29, 30, 31, 31, 31, 3 of those, 32, 34, 35, 37, 38, 40, 41, 43, 44, 48, 53. And I've got 28 values entered in, okay? All right. So I'm mainly doing this one because I want to just make sure y'all remember how to do it on the calculator. Now, if you wanted to, sure, you can add all of those up, add all 28 values up, get their sum, and then divide by 28, and that will give you the mean, okay? So you can do that. You can also get the median by hand if you want to as well. You would put them all in order from smallest to biggest. And then the median would be the middle number in the middle. If there are an odd number, it would be that exact number in the middle. If there's an even number of data entries, then you'll take the 2 in the middle and add them together and divide by 2, average them out. But again, the calculator will do all this for you, okay? And then keep in mind that the mode is just the most repeated number, okay? You could have a set that has 2 modes. It may be bimodal. But again, mode is simply most repeated. Okay, so I'm gonna let the calculator do it for me. I just wanted to let you know that you could do it, but I'm gonna let the calculator do it for me by simply entering them into the list and now pressing stat, and I'm ready to calc. And this is one variable stats because it's just single X values, one variable. It's not like an ordered pair X and Y, okay? We don't have an X and a Y ordered pair. These are just single X values. So number one, use one variable stats, press enter. You don't have a frequency list, okay? So clear that. Just go down and press clear right there. And then your list is L1, of course, that's where we put the values in, and then go calculate. So your mean is X bar, 29.25, and it says round to 1 decimal, so 29.3. And it says, does the mean represent the center? Yes, the mean is a measure of center. It is a measure of central tendency. So it is a measure of center. So A right here. Now it asks for the median. Well, if you arrow down some, the median is right there, 30.5. And it says round to 1 decimal, so that is 1 decimal. So we just keep that anyway. You never round the median. You just keep it as is. So that's why they said to 1 decimal, okay? So the median is MED from the calculator. The mean is X bar. So just be aware of that. From calculator is called MED, okay? And it says, does the median represent the center? Yes, it does. It is a measure of center, okay? Last part is find the mode. And if you have more than one mode, if it's bimodal, you'll enter both of them in, separating them with a comma. So with the mode, you have to look at the data set and just see if there is an entry that's repeated more than the others. So 28 was repeated 3 times right there. And 31 also was repeated 3 times. Is there anything that was repeated 4 times that could beat those out? I don't think so. So it looks like we have a data set that is bimodal. So 28, comma 31. We had two modes. And then it says, does the mode represent a typical entry of the data set? Yes. That is by definition what the mode is. Most repeated or typical entry. Okay. All right, so again, that's module 2, dealing with measures of central tendency, module 2, 2.1. This next one, number 10, I definitely want to work number 10. Let me show you number 9 just in case as well. We did see number 9 in module 2, but I don't know if y'all will remember that one, so I do want to show you this one as well. So what we're trying to do on number 9 is figure out the average daily balance for the month of April, the mean daily balance for the month of April. We're told that for 24 days, it had, or she had in the month of April, the checking account had a balance of 541 for 24 days. So basically, we're saying we would have 541 written out 24 times. Or we could simply say 541, instead of writing it 24 times, 541, 541, 541, we can just say 541 times 24. Okay. Then we're told that we had 2,320 for 2 days. So we're going to say plus 2320 and 2320 twice, or 2320 times 2. There were 2 days that had $2,320 in the account. And then there were 4 days where there was only $263 in the account. So we could write out 263 4 times and add that to these amounts. Or simply say plus 263 times 4. So you will add all of those up. You'll get these products 541 times 24, 541 times 24. That's 12 or 129.84. 2320 times 2, that's 4640. And then 263 times 4, that's 1052. So we're going to get that sum, 129.84 plus 4640 plus 1052. That is 18,676. And in the month of April, there were 30 days. 24 plus 2 more is 26. 26 plus 4 more is 30. So 18,676 divided by 30 days gives us a mean daily balance of $622 and about 53 cents. 622.53. And that's what we'll put here. 622.56 or 53. Okay. For number 10, we're asked to find the range, the mean, variance, and standard deviation for this population data set. Okay. So this data set represents the regular season wins, the number of regular season wins for 10 different football teams in a given season. And we're told that this is the population. All right. So to get the range, there is no formula really that we put into the calculator. To get the range, you simply need to identify the maximum number, the biggest number, and the minimum number, and just subtract them. So the range is your max number minus your min number. Your max is 15, and your min looks like it is 2. So you have a range of 13. Okay? Population mean, variance, and deviation, I will use my calculator on those. So I'm going to put these numbers into a list, and I'm going to use probably list 1. And then I will get the mean, and I'll get the deviation, and I'll then be able to get the variance. Okay? So population mean, even though technically, yes, it is a population, the value from the calculator will actually be called X bar. Okay? Because they have the exact same formula, the calculator just calls the mean X bar by default, even though technically it's population mean, okay? Now the population variance, that is sigma squared, okay? It has a very specific symbol, as does the population deviation. It is sigma, okay? So let's put these numbers into our list. Press stat, edit is highlighted, you're gonna edit, so press enter. Let's clear out list 1. Let's arrow up and press clear, enter. And our numbers are 2, 8, 15, 2, 14, 8, 12, 9, 3, 7. So we got 10 values entered in. You always double check them. 2, 8, 15, 2, 14, 8, 12, 9, 3, 7. So we're good there. Now you're ready to get those other values, okay? So after you put the values into your list, then you press the stat key again, and you go over to calc, and you're going to use number 1 variable stats. So we only have one list. We don't have a frequency list, so make sure that's clear. And your list of values were in list 1, so we got that covered. Then go to calculate. All right, and so your mean, remember I told you by default it's called X bar. So your population mean is 8. If we had a decimal, we would round it to the tenths, but this is just a whole number. The population variance is not given. So we can find it by getting the deviation and squaring it. Okay, so look at the symbols. Standard deviation, population standard deviation is sigma. Population variance is sigma squared. So we're going to take sigma, which on our calculator is called sigma sub x. We're going to take that, square it so that we can get the variance. So 4.472135,955. All right, so we jotted that down, and now we're ready to take that number and square it so that we can get our variance. All right, so let's square that. I should have wrote variance instead of the symbol. Let me put variance here. All right, so let's square 4.472135,955. Let me make sure 4.47135. All right, now let's square that. So we get 20. And that's why I actually like to use all the digits, because if I rounded that off, it would not have rounded off to just be that simple whole number 20. So using every digit and then squaring it gave us the variance. Now the deviation, well, that was just this number before you squared it. So we'll take this number and we'll just round that off to the tenths. So we'll make that 4.5. Make that 4.5. Okay. All right. Okay. Number 11 is another problem that we've seen in Module 2, where we're asked to find the CV, the coefficient of variation. Well, the coefficient of variation, whether you have a population or a sample, is going to be just the ratio of the mean and the deviation. Okay. So depending upon whether you have a sample or population is whether or not you'll use the standard deviation S when it's a sample, or the standard deviation sigma when it's a population. Okay. So when we have a population, I'm gonna put population, it will be sigma divided by mean mu times 100%. That's when you have a population. When it's a sample, it will be S over the mean X bar times 100. And the 100 is just making it a percent. That's all. And I don't know why I put that up there. It should have been written right here. I wrote it up there like it goes with that problem. It goes to number 11. So let's just see what we're dealing with. Are we dealing with a sample or a population? It says the ages and weights in pounds of all running backs for a football team are listed. So we're dealing with a population, okay? So coefficient of variation for a population is sigma, which is the standard deviation, divided by the mean, which in our case is technically mean mu because we're dealing with a population. And then notice that they do have percent symbols. So we are going to say times 100 to make it a percent. So we will have to use this formula. We'll need the mean and the deviation for both of these sets of data. You'll use the data sets individually. So you'll find the coefficient of variation for the weights and then you'll find the coefficient of variation for the ages. So for the weights, I'm going to place these values into the calculator. Okay. So we'll press Stat, Edit, and I'm going to clear out that list. Okay. So for my weights, I'm putting in 197, 192, 210, 182, 192, 206, 200, 216. Okay. So I'm just doing this for the weights first. So I need to get the deviation and the mean for the weights. So after I enter those in, then I press Stat. Okay. And I go over to Calc. And we are using number one variable stats. My list is L1. So I go calculate. Because remember, I have to pull the deviation and the mean. So for the weights, our deviation, our standard deviation is sigma, because it's the population, 10.307. And then my mean is 199.375. And remember, we use X bar, even though it's population, and even though the population mean is called mu. Remember, your calculator calls the mean X bar by default. So 10.307 divided by 199.375, 0.05169, but then we're going to say times 100. So I'm going to say that times 100. So 5.169, rounding that to one decimal, 5.2. Okay. Okay. Then we're going to do the same thing for the ages. So we'll put the ages into our calculator, into our list. So I press Stat again. Edit is highlighted. I'm going to edit by pressing Enter. And remember how we cleared the list? You go up to the name, you press Clear, Enter. So ages is 28, 26, 28, 29, 29, 24, 31, 28. Okay. All right. And I believe we've got 1, 2, 3, 4, 5, 6, 7, 8, all 8 values entered in. Yep. So now we're ready to work with it. So now we press Stat again, go over to Calc, number 1. No frequency list, I just go down to Calculate. All right, so for the ages, the deviation is 1.9645529. I try to go several decimal places throughout the number and then round at the end. Then the mean is 27.875 times 100. Okay. So 1.9645529 divided by 27.875, and then times 100, because I got the ratio first, and that was 0.07, and then times 100. So that is about 7.047. Rounding that to one decimal, that would still just be 7.0. And then it just says compare the results. So the ages have more variability because it has the larger coefficient of variation. So ages, let me see. Ages are more variable than weights. So that would be A. Okay. So that was again module 2. Let's take a look and see what we need to do on those. Okay. Okay. Number 12 here is the 5-number summary. Let me just show you this one. Very straightforward. If you remember, just put it in your list, put the numbers into your list, and the calculator will find all of these values for you, the minimum, the maximum, Q1, Q2, and Q3. So when you put it into your list, you press Stat, Edit is highlighted, press Enter, and you're going to put it in List 1. Go up to the name, press Clear, Enter. So List 1, I've got 3, 8, 8, 6, 2, 9, 8, 7, 9, 6, 9, 5, 2, 6, 2, 9, 8, 7, 7, 9. So we got 20 values entered in, and now we want the 5-number summary. After you put them into your list, you press Stat, go over to Calc, and it's number 1 still. Go down to Calculate. You can see the minimum right there. Minimum number is 2. The smallest number in the data set is 2. Then you got, if you arrow down, you can see the rest. But then after the minimum, you got Q1. Don't round it. It tells you right there, do not round. Keep it exact. So 5.5. Q2 is the median on the calculator. Q2 is called MED, the median. And Q3 is 8.5. And then your max is 9. That's it. And then you can, of course, draw a sketch of this. The easiest thing is to just do a quick little sketch right here. Create your number line. The numbers range from what, 2 to 9. So you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then create your box. Your box is created at Q1 and Q3. And then your line segment inside the box is at Q2, and then you extend your whiskers out from the box. So, for example, your Q1 value is 5.5, 1, 2, 3, 4, 5. So between 5 and 6 would be Q1. Your Q3 value is at 8.5, so that's 9. So between 8 and 9. Your Q2 value is at 7, 5, 6, 7. And then your whiskers extend from Q1 to your minimum and Q3 to your max. Okay? So just look carefully at where the values start and stop. Make sure you've got your, it looks like B and C are pretty much the ones I'm determining between, I think, because it goes from 2 to 9. You've got your Q3 value at 8.5, which is right, between 8 and 9, whereas that one has it at 8. And that one has it at 8 also. So it has to be C. Has to be C. Okay. Number 13, I'm just going to put the z-score formula on here. That would be x minus mean mu divided by sigma. You'll just transform the x value to a z-score, It says the mean age is 27.1, so that's your mean mu with the standard deviation sigma of 3.3, and it says the winner in 1 year was 28, so X is 28. So 28 minus 27.1 over 3.3. Okay, so you're making it into a z-score. Let's see, my video is running a little long, so I'm trying to get through it a little bit faster. I don't want it to cut off on me. Number 14, you're also writing those as z-scores as well. And then 15 and 16 is your first look at probability. So that's the first section in module 3, 3.1. So number 15 is asking what would be the probability of the next person being selected saying that they are very prepared. So you would first get the total frequency by adding all of those up. 280 plus 969 plus 589 plus 327 plus 47. So 2212. And then specifically, what is the probability of choosing the next person and that next person being very prepared? Well, that would be 280. How many said they were very prepared out of the total? 2212. And of course, you'll round that to a decimal. Okay. Number 16 is also looking at probability. This one is asking you about conditional probability because it says given, you're given something. So we'll look at this one. It says the accompanying table shows the number of male and female students in a particular country who receive bachelor's degrees in business. So you've got the male total out here at this school in this particular country, or let me not say at the school, all the males in this particular country, 809,270, and of them, the number that earn business degrees and the ones who earn non-business degrees. Same thing with females. You got the total females here, and then of the females, those that earn business degrees, those did not. And then down here in the bottom right corner is just the total of people in general. And at the bottom of the columns, the bottom of the business column, the total number of business degrees, regardless of gender, just the total number altogether. And then the total number altogether non-business degrees, regardless of gender, total number. So for part A, it says find the probability that a randomly selected student is male, given that the student received a business degree. So part A, I'll put right here for number 16, probability that the student is male, given, remember that line, that bar represents given that they earned a business degree. And we looked at this one before, but I do remember some students struggling with it a little bit. So the given condition is what follows that bar, is what follows the given. That either will reduce your sample space by so many, or it will become your sample space. And in this case, it becomes our sample space because basically it's asking us to find the probability of randomly selecting a male given that they earned a business degree. So in other words, you would ask yourself, given all the students who earned a business degree, how many were male? That's how you have to answer that question, or how you have to determine that question. So given everybody that earned a business degree, how many were male? So of everyone that earned a business degree, so basically how you would write it or how you would pose the question, given out of everyone who earned a business degree, how many were male? That is the question. So out of the total business degrees earned, which is 361,462, 188,102 were males. So 188,102 out of 361,462. 188,102, 361,462. So that gives us 0.52039, and we're rounding that to 3 decimals, so 0.520. 0.520. Okay. So of the business degrees, how many were male? So it's like, even though this was the original total sample space, because you're only interested in those that earned the business degree, so of those that earned the business degree, how many were male? Probability of them choosing a male. Okay. Part B, find the probability that a randomly selected student received a business degree given that the student is female. So now, probability earned a business degree given female. So female follows the word given this time. So that means of all the female students, of this total female students, how many earned a business degree? 173,360. So of the total female students, so of the 1,093,335, the business degrees, 173,360. So 173,360 out of 10,93,335, 10,93,335, yeah. We get 0.15856. So that would be rounded off to 3 decimals, 0.159. Okay. And so here you would say, given female, how many earned, or of all the female, so of all the females, how many earned business degrees? That is the question. Okay. All right. There's one more question that I can look at, and it's number 17, but the remaining two are just asking you a little terminology. I won't worry about those. So I'll look at number 17, and then that will be the end of this video. So number 17 says 2 cards. Let me just take this off. 2 cards are selected from a standard deck of 52 playing cards. The first card is not replaced before the second card is selected. Find the probability of selecting a jack and then selecting a 10. So number 17, we're selecting 2 cards. Probability of selecting a jack, so the jack is first, and then selecting a 10. And keep in mind, this is without replacement. Because remember, when you're dealing with the and, when you're looking for a probability of 2 events together, combined with the word and, that indicates multiplication rule, which means we have to see whether or not the events are independent or dependent. And that will be affected by this statement right here. So we are not replacing that first card before we select the second one. We leave it out, okay? So this is connected by the word and, so we're dealing with the multiplication rule, okay, for probability, multiplication rule for probability, and these are dependent events. They're dependent because we are not placing that first card back before we select the second. So because they're dependent, we have to account for the fact that the jack, when it comes out first, or whatever we pull first, will affect that second probability, the probability for the second card. So probability of selecting a jack times the probability of selecting a 10, given that a jack was already pulled out. Okay? So it is multiplication, but we're dealing with dependent events. So the probability for the second event, probability of pulling a 10, is affected by the fact that we already pulled a jack. Okay? So the probability of pulling a jack, and keep in mind, I will have the deck of cards copied as well for you to use when you're taking the test next week. Okay, I will have the fact sheets for you as well as the standard deck of cards. I know everybody doesn't play cards. Okay, so probability of selecting a jack. Well, there are in your deck of cards, there are 4 jacks out of 52 cards total. And you should still have the deck that I gave y'all before when we were working in this module, back when we were working in module 3. So the probability of pulling a jack, you got 4 jacks. Every suit has a jack, okay? Remember, you got 4 suits, so 4 out of 52. Now, suppose that we wrote that probability down and then we actually ended up pulling a jack. Lo and behold, we pulled a jack. So we pulled that jack out and the jack is no longer in the deck anymore. So now we get ready to find the probability of us selecting a 10, given that we already pulled the jack out, the jack is gone, then we only have 51 cards now in our deck, and there are still 4 10 cards. Every suit has a 10, 10 of hearts, 10 of spades, 10 of clubs, 10 of diamonds. So there are 4 10s, but now out of 51 cards because you already pulled the jack out. So 4 out of 52 times 4 out of 51, rounded to 3 decimals, is like 0.006 or something like that. Point 0.006. Okay. And that wraps up practice exam for the comprehensive final part A. Part A. I'll be back with part B. Thank you.